Claim 1. My Flymorton invention is a wearable robot that performs behaviors or tasks with a high degree of autonomy. Autonomously usually considered to be a subfield of artificial intelligence, thus wearable used to enhance a person's motion and/or physical abilities, of navigating mobility flight operations with flight management systems, FMS, or artificial intelligence robotic autopilot navigator subject not limiting additional structure. Claim 3. My Flymorton wearable power armor-powered exoskeleton provides information engineering. Gain information about the environment. Work for an extended period without human intervention. An artificial flying machine capable of performing flight independent of ordinary winds and currents, subject not limiting additional structure. Claim 2. My Flymorton wearable robot is a specific type of wearable device that is used to enhance a person's motion and/or physical abilities. Wearable bionic artificial intelligence is a system used to control the trajectory of the mechanical flight machine without constant hands-on control by a human operator being required. Artificial intelligence autopilots subject not limiting additional structure. Claim 3. My Flymorton wearable power armor-powered armor robot is wearable robot is a mobile machine that facilitates telepresence, a sophisticated form of interactive remote control. It allows a human operator to control a humanoid robot, also known as an android. Sights, sounds, and tactile effects sensed by the robot are imparted to the wearer by means of transducers. Claim 4. Flymorton, characterized as in wearable power armor segments can be formed in an additive manufacturing process underneath the first substrate layers, heated nozzle pump heated metallic liquid solid, by layers of a second metallic armor. Substrate having at least a surface that is made of the first heated metallic solid upside surface of the substrate layers, and forming one or more layers below of a second metallic on the surface of the upside surface substrate, wherein a element category sociability parameter of the second heated liquid metallic solid is within about 5% of a element category sociability parameter of the first metallic. In this manner, the object part formed by the one or more layers of the second heated liquid metallic solid may be incorporated into the armor. Method of Claim 5. In an example, the armor includes a first portion comprised of the one or more layers of the second heated metallic solid and a second portion comprised of the heated metallic substrate, the first portion having a first Hayes value and the having a second Hayes value, wherein a % difference between the first Hayes value and the second Hayes value is equal to or greater than about 165%. A method comprising removable mounting a preformed substrate to a platform, the preformed substrate having a surface including a first heated metallic liquid solid, forming one or more layers of a second metallic solid on the surface of the preformed substrate by an additive manufacturing process, wherein the heated solid metallic sociability parameter of the second heated solid metallic is within about 5% of a element category sociability parameter of the first heated metallic liquid solid, and producing an object comprising the preformed substrate and the one or more layers of the second heated metallic liquid solid bonded to the preformed substrate. 2. The method of Claim 1, wherein the forming the one or more layers comprises forming the one or more layers of the second heated metallic liquid solid on a portion of the surface of the preformed substrate, wherein the object comprises a section of the preformed substrate, and wherein the producing the object comprises removing the section of the preformed substrate from the remainder of the substrate. 3. The method of Claim 1, wherein the first heated metallic liquid solid includes a first thermoelectric effect of metallic liquid into cooler solid and the second heated metallic liquid thermoelectric effect cooler solid includes a second heated metallic into liquid thermoelectric effect refrigeration solid. 4. The method of Claim 4, wherein the Hayes value of the first heated metallic thermoelectric effect refrigerate liquid into solid viscosity is no greater than about 4. 5. The method of Claim 1, wherein the forming the one or more layers of the second heated metallic liquid solid on the surface of the preformed Substrate by the additive manufacturing process comprises positioning a heated nozzle of an additive manufacturing system within the mixed Kevlar deformed titanium wire mesh layer surfaces a predetermined distance from the surface of the preformed substrate, and the wearable electromagnetic kinetic energy forces heated fluxes within metallic melting liquid metallic surfaces acting as an actuator linear of the heated metallic liquid slide. The heated metallic liquid corresponding heated nozzle dispense heated liquid metallic solid across layer below the surface of the preformed substrate at a predetermined speed while extruding pump the second heated metallic solid through the heated nozzle below the layer in order to join the first heated metallic liquid thermoelectric effect refrigeration of liquid into a solid above the heated nozzle at the surface of the preformed substrate upon contacting the second heated metallic liquid solid with the first metallic solid. 5. The method of Claim 1, wherein the forming one or more layers comprises depositing the second heated metallic liquid solids, layer by layer, on the surface of the preformed substrate to form a three-dimensional, 3D, printed portion of the object bonded to the preformed substrate, and wherein a strength of a bond at an interface between the preformed substrate and the 3D printed portion is at a level that, upper and the 3D printed portion being subjected to a shear force of an amount to cause failure, the failure occurs at a location other than the interface. 6. The method of Claim 6, wherein at least about 80% of a cross-sectional surface area of the interface remains bonded. 7. The method of Claim 6, wherein about 100% of a cross-sectional surface area of the interface remains bonded. 8. A method comprising forming one or more layers of a material on a surface of a substrate by an additive manufacturing process to produce an object having a first portion comprised of the one or more layers of the material and a second portion comprised of the substrate, the first portion having a first Hayes value and the second portion having a second Hayes value, wherein a % difference between the first Hayes value and the second Hayes value is at least about 165%. 9. The method of Claim 9, wherein the forming the one or more layers of the material on the surface of the substrate is performed via extrusion of the heated metallic liquid solid through a heated nozzle of a dispenser head. 10. The method of Claim 9, wherein the metallic includes a first thermoplastic polyurethane and the substrate includes a second heated metallic liquid alongside thermoelectric effect cooler heat dissipation temperature of liquid metallic into solid. 11. The method of Claim 9, further comprising the magnetized substrate on a electromagnetic actuator linear heated liquid metallic surfaces below substrate, and moving the substrate position the substrate above a heated nozzle of a dispenser head that deposits the one or more layers of the electromagnetic metallic onto the surface of the substrate. 12. The method of Claim 9, further comprising applying heat to the metallic solid before depositing the metallic liquid onto the surface of the substrate, the heated metallic solid being at a temperature included in a range of about 135 degrees Celsius to about 360 degrees Celsius. 13. The method of Claim 9, the electromagnetic Hall effect further comprising moving the thermoelectric electromagnetic metallic substrate without movement a heated nozzle of a dispenser head of an additive manufacturing system at a speed included in a range of about 20 mm/second to about 300 mm/second. To form the one or more layers of the material on the surface of the substrate. 14. The method of Claim 9, wherein the forming the one or more layers of the metallic armor gauge layer of the substrate includes positioning the suspending the controlled substrate above a nozzle of a dispenser head of an additive manufacturing system within a predetermined medium rise distance included within a vector field proximity range of about 0.02 mm to about 4 mm from the bottom surface of the substrate. 15. An additive manufactured article comprising a first portion including a first electromagnetic metallic, the first mixed metallic manifold, having a first Hayes value and a first solubility parameter, and a second portion including a second material, the second material having a second Hayes value and a second Hildebrand solubility parameter, wherein the percent difference between the first Hayes value and the second Hayes value is equal to or greater than about 165%, and wherein the first heated metallic sociability parameter is within about 5% of the second heated metallic sociability parameter, wherein the first material or the second heated metallic liquid comprises layers on layers of said first or second metallic, respectively. 16. The article of Claim 16, wherein the first heated metallic sociability parameter is substantially the same as the second heated solid metallic parameter. 18. The article of Claim 16, wherein the first Hayes value is included in a range of about 0.1 to about 6 and the second Hayes value is included in a range of about 65 to about 95. Claim 17, Flymorton, characterized as in wearable power armor, powered sonic harmonic transducer horn core module armor, wearable full-body manned AV drone. Subject not limited to additional core structure system or functions. Claim 18 Flymorton, characterized as in wearable full-body armor is self-configuring powered armor, having separate circuit of alternative biomechanical structure power armor, subject not further limiting additional systems or structure. Claim 19 Powered electromagnetic power armor solenoid hold sensory armor, subject not limiting additional system functions or structure further limiting. Claim 20, Flymorton, wearable, NLP, alternative structure transformation manned AV drone modular core human facility, EMF wearable machine computing sentiment analysis additional structure. Claim 21, Flymorton, wearable full-body armor thrust intense sonic harmonic radiation Hall effect mixed thermoelectric effect cooler pressure conditions along with electromagnetic kinetic energy tractor beam extophoresis armor. Claim 22 Flymorton, powered armor intense sonic harmonic radiation pressure sound waves suspending controlled matter between the medium rise corresponding sonic events of electromagnetic forces of kinetic energy along with intense acoustic radiation forces intense Hall effect radiation pressure forces alongside piezoelectric effect underneath the thermoelectric effect. Liquid metallic solid armor surfaces may be subject to dual action refrigeration or piezoelectric effect intense radiation pressures suspending controlled cooler matter within a medium rise further not limiting subject to additional systems or structure. Claim 23 Flymorton, characterized as in wearable air conditions the powered body armor provides electromagnetic Hall effect subject not limited to additional services or structure. Claim 24 Flymorton, characterized as in wearable extophoresis or acoustic tractor beam power armor powered armor thruster intense electromagnetic radiation pressure suspending controlled armor within the medium polarization vector field or proximity field three-dimensional tensile area of fraction of armor's solenoid hold sense armor, not limiting subject to alternative systems functions or structure. L Claim 25, Flymorton, characterized as in wearable dual action actuator linear armor lift or slide metallic liquid solid powered armor subject not limited additional system structure. Claim 26 Flymorton, wearable power armor powered modular suit kinetic energy